This call is now being recorded.
Again, good afternoon to all. So, this afternoon, our topic will be on field effect transistors. Field effect transistors. So, I'm only going to supplement the notes or the information that you already gathered. No? At least na may idea daan sa FET. Pili na po kayo ko ang nakadaga na i-explain. So, pwede na kayo diretso mag-add to sa FET biasing circuits because almost complete naman ninyo ang kuan, no? Inyo ang mga information na nag-gather here sa inyong notes. And that goes to each one of you, no? So, nakagather mo similarities, advantages, disadvantages as compared to the BJT. Classifications, no? What are the different classifications of field effect transistors? There are three, diba? So, when you say FET or field effect transistor, we have Jfets, MOSFETs, and MESFETs. No? MOSFETs and MESFETs. So, when you say MOSFET pod or MESFET, napos siya do ka flavor. Sa ganito, two types of MOSFETs and two types of MESFETs. Okay, very good. Enhancement and depletion type MOSFETs and MESFETs. So again, ako lang idungag or if ever naman ni sa inyong notes, akong i-emphasize more because mo nga mga information ang magamit nato when we analyze FET biasing circuits and puhon-puhon pag-design po ng FET amplifiers. Pero, well, truth be told, dili siya lisod na, no? Dili na talaga maglisod og analyze og FET circuits because na naman tayo intuition nga na-gather or na-learn from sa pag-analyze og design sa BJT, no? Kasi masayon gyud ang FET gamiton kaysa sa BJT, no? So, just a sort of reminder or review, transistors, whether FETs or BJTs, are used mainly for switching and for amplifying. Okay. Amplifying. Ang gini main nga purposes for transistors, no? Even BJTs. So samot na sa FET. FETs or FET circuits could be used in switching applications and for amplification. As compared to the BJT, which is a current-controlled current source, okay? As pointed out by you guys in your notes, the FET is a voltage-controlled current source. And yeah, voltage-controlled current source. So, natay tulo ka klase nga FETs. We have the Jfet or the junction FET. We have the MOSFET. And we have the MESFET. MESFET. Okay. So for amplification, mostly or much better gamito na ang Jfet, no? For amplifier circuits. Pwede naman gyapon magamit ang MOSFET o MESFET. Pero or at least ang Jfet mas forte is to be used as an amplifier. Ang MOSFET is mainly used for digital applications, no? Digital. So kung digital applications, or more specifically, mga building blocks computers like memories, no, microprocessors, MOSFET na siya, no. MOSFET ang transistor nga nasa sulod sa atong mga microprocessors, microcontrollers, and such. Basta kay digital applications, kaya its most basic na use ang computers kung gid biya na, no, gahandle lang gid sila og two types of signal, on and off, meaning switching na gihapon. Okay? MESFETs could be used also for amplification and switching, pero they are more costly. Okay? More costly. Mo naman nila disadvantage. And mas magamit siya sa RF applications or radio frequency, no? So high frequency circuits where the frequency is high. The frequency. But for the remainder of our discussion, we will be focusing on the Jfet as an amplifier and the MOSFET as switches. Okay? And actually, e-MOSFET pag ganyan itong ito, no? More specific ta sa e-MOSFET or enhancement type MOSFET. So, diha ta mo mas more mo focus sa atong pag-learn of field effect transistors. Okay? So, sa mga characteristics and formulas. Characteristics sa atong sa atong FET. No? Could any of you give me at least one? Mag-ihag yung salient feature sa field effect transistors. Nagid na yung mag-isa, nga mulabaw sa tanan, nga main na characteristic sa atong FET. Sige, basig nasa inyong notes. Okay, very good. The field effect transistor has a very high input impedance. No? So, yung input impedance is very high. Okay? So, na yung atong FET, diba? FET. Three terminals gapon. This is BJT. It has the gate terminal, the drain terminal, and the source terminal. So gate, maragod gyapon the usual nga way magamit sa word nga gate, mar siya control, no, control na mechanism, no? Gate allows something to pass through or iyahang pugnan. So aptly named po ang source and drain because kung electron flow atong gamiton, the electrons flow from the source to the drain man gyud, no? When electrons flow sa kakibale, no? From the source to the drain, that's why source ang tawag, then mo adto sa drain. But tungod kay gagamit ang conventional current flow, ang atong kuan is from the drain to the source, no? Atong flow sa atong current from the drain to the source. The operation of our FET will be controlled by tungod kay voltage controlled current source siya, it will be controlled by the voltage that is applied at the gate to source junction. Now, another feature or characteristic of our FET, tungod kay dako iyang input impedance at the gate, kay mo man ang atong input terminal, dili man padulong atong signal sa gate, is IG, the current sa gate will always be equal to 0 amperes. So ato na lang i-memorize daan. IG is equal to 0. Okay? Because of the high input impedance of our device. Meaning, if mag-KCL ta, IG, it's supposed to be IG plus ID equal to IS, right? But tungod kay IG is equal to 0, That's another characteristic of the FET. ID is equal to, yes, correct, IS. So, muna iyahang kuan. Another characteristic or formula. Sa baba. Generally speaking, I think mo na siya. No? And one last thing pag yun, no? Final thing na nakapa-differ sa atong FET, kung i-compare nato sa BJT, is that its ID or the current sa drain, sulod sa drain nato nga terminal, is defined by Shaklee's equation. No? ID is defined by Shaklee equation. At least, sa tunan nato nga i-memorize, isa sa mga dapat nato i-memorize with regard to dealing with field effect transistors. Shaklee equation. No? Named after William Shaklee, the inventor of the transistor, I think. ID is equal to ID SS quantity 1 minus VGS over VP squared. So, mo lang ning tulo ng mga relationships and or formulas atong dapat i-remember when dealing with FET amplifiers, specifically the Jfet. Okay, specifically the Jfet. So IG, the gate current is always equal to 0. ID is equal to IS, and ID is equal to or is defined by the Shaklee equation, equal to IDSS 1 minus VGS over VP. Now, so ning uban dire, IDSS asa na sa makita ug si VP. IDSS and VP are both constants. No? I'll explain later on na sila. So, constants. Kung BJT pa, muna sila mga beta. No? Muna yung characteristics sa atong device or device parameters na sila. So, if constants na sila, saan sila makita? Dito na sila makita sa specification sheet. Okay? So, sa specs. Dali na sila locate. So, kung saan si IDSS o kung saan po na si VP. No? Of course, VGS is our input voltage across the gate and source terminal. Although makita si IDSS o si VP sa specs, ato po dapat mabalan sa gina sila. No? So, or this graph is the relationship between VDS and ID. Could describe by this curve. Na. This is, of course, kaninga graph. This is the graph of VGS at this level. No? This level. Or when VGS is equal to 0. This is when VGS, di man makita sa graph, kaya this is a graph of VDS and ID. VGS is equal to 0 nga graph. Now, kung saan sila, no? Makita na to na at some specific point, no? Somewhere right here, magplateau ang value sa atong ID. No? So, at this point, medyo linear pa ang relationship. At small VDS, small ID. No? At this value of VDS, ano yung value sa ID? No? So, linear pa man siya. Pero maabot nga point, no? There's a specific point or specific voltage level na no matter how high or na specific na current level, I mean, no? Kana siya. No matter how high na ang voltage sa atong VDS across the terminals drain and source, the current nga mo flow sa atong FET is nag-saturate na. No? So what are these values? No? Unsa ni siya nga point? No? When VDS would reach a value that's equal to this one, VP, no? Mag-saturate na dahil ng atong current. Saturate. No? Pag maabot na si VP. And this VP is what we call the pinch-off voltage. Okay. So pinch-off voltage is when VGS is 0. Okay. When VGS is 0, at what level will the current saturate? At this value, VP. And also po nga value, no? Also nga value. This is called ID SS. Munang value sa atong ID at saturation. Nag-saturate ng atong ID. Okay? So summarizing everything, if this is a Jfet, specifically Jfet na siya, then I hope mo coincide ni sa inyo hang na research. Normally, current is flowing. Okay? Normally, current is flowing sa atong device, specifically ID. Now, kung mag-apply tawag sufficient amount of voltage across VGS, kung mag-apply tawag specific na kuan na voltage din sa VGS, si current nato ID is cut off, no? Ma-zero. Okay? The opposite tayo is true. If off si VGS, meaning if wala tayo i-apply nga voltage dire sa gate to source terminal, just like I've said earlier, na mo flow nga current kay from drain to the source up until maabot ang value nga saturation level, which is equal to IDSS. So kung ato tong i-summarize, if off ang atong gate to source na terminal, meaning wala tayo i-apply nga voltage, no? If off ni siya, on si device. And if on si VGS, meaning na i-voltage today, off si device. Okay? Sakto ba to? The same ba tag conclusion? Or naabot mo giana nga kuan sa inyo hang research nga notes? Off ni si gate, kung off ni siya, saturated si kuan, saturated si drain. Pero if na voltage dire, ma-off si drain or ma-cut off siya kibaling. So, yan na ang characteristics sa atong FET. Okay? Now, what are some disadvantages of FETs then, as compared to using BJTs? Are there instances nga mas kada gamiton si BJT kaysa sa ni FET? Nga ba? Siguro isa sa, sige daw, so may isa sa mga disadvantage sa FET compared to the BJT. Kaya base akong kuha dire, masayon pa man siya gamiton, no? Mas convenient. And later, mas ma-appreciate pa rin nato kay ang analysis kay mas simpler. No? What is one apparent disadvantage of FETs? Wala? Wala, ikuan? Low voltage gain. Relatively speaking, mas dili ta ka-expect og dako ang voltage gain from FETs. Okay, that's one. Good. Isa pa? Yes, it's very sensitive, no? That's correct. Especially MOSFET. Because of static discharges. Yeah. Kani, especially discrete na MOSFETs, di daw pwede hawitan normally using hands. Dapat namoy natin static discharge nga belt or wrist strap para mawala ang build-up of static electricity because of the physical construction of our MOSFET. Yes, that's good. That's another disadvantage of the FET kay mas sensitive siya, no? Pa ba? May? Among sa iyang advantages noon is aside sa ease of using it is more temperature stabler. Ang small size, I think in most cases advantage na siya, no? Tungod ana tungod aning MOSFET specifically naka-create og or naka-create ang humankind og mga for every year ga-create og mas gamay pagid nga mas gamay nga microprocessors, no? Tungod kay pwede ma-miniaturize ang MOSFET. Okay. Yes, for frequency response. That's also one disadvantage of FET. No? Whatever frequency response may mean, ma-encounter na to na few weeks from now. Pero just try to remember na yes, mas poor ang iyahang frequency response compared to the BJT. No? Actually, because of these disadvantages and some of the advantages po na atong na mention karon lang, more useful good ang FETs as switching circuits, no, kaysa sa amplifiers. Pwede noon ta makabuhat og amplifier sa FET, no, using Jfet. Pero again, mas mag-shine good ang FET more if gi-use siya as switch, no. And dili na mag-mind sa gain, dili na mag-mind sa iyahang actually, sometimes hindi kita mag-mind sa values sa ato ipang-connect sa iya nga mga components tungod kay gigamit ato siya as switching circuit. No? Pero kana ato na siya ma-encounter soon. Right. With that, let's try to solve, okay? FET biasing circuits. So if na-fixed bias, self-bias, voltage divider sa BJT, the same gapon ang configuration sa FET. No? We'll start gapon with fixed bias configuration. So to ang sa FET, iyahang symbol. Maging ana. No? So this is a FET bias configuration for a Jfet amplifier. Jfet na device. The source that's connected to the drain terminal is called VDD. Kana is the drain resistor RD. Source is resistor RS. Gate resistor RG. Ay, well, actually, wala pa day RS, no? Kung pa day ni. Wire pa day ni siya. Sorry. Wala pa day RS. Fixed bias pa man day ni. So, akong i-draw na lang. Wala. So, this is a fixed bias Jfet amplifier. Ang simple lang ito na awon. VDD. And this is tungod kay voltage source niya na connect siya sa gate. This is what you call VGG. So, mag-derive to equation. So, just my equation. Let's remember that IG is equal to 0. No? So, if IG is equal to 0, wala current nga mo-flow sa atong RG. Meaning, the voltage across RG is IG RG, but IG is 0. So, it's as if wala niya exist ni nga resistor, no? Si RG. How about dire, KBL ta dire nga side. Okay. VDD minus IDRD minus VDS is equal to 0. So, mga na siya, no? KBL, kibalita. Dito ako na KBL. Sa input side. BGG. KBL lugar to diya. BGG minus IGRG minus VGS is equal to 0. Okay? BGG minus IGRG minus VGS. Gano'n naman is equal to 0. BGG minus IGRG minus VGS equal to 0. But IG is 0. Therefore, VGS is equal to VGG for the fixed bias circuit. How about sa other side? Sa right side or sa talaga input. And so, sa output, I mean. Diba? Kung mag-KVL to diba, BDD minus IDRD minus VDS is equal to 0. Okay, grand naman. So, VDD minus IDRD minus VDS. VDS is equal to 0. Constant, unknown, constant. VDD is constant and given. Same with RD. VDS is of course unknown. Si ID, kung wala pa natin ako si ID, we have one equation, two unknowns. But again, let's not forget Shaklee equation. ID is equal to IDSS 1 minus BGS or BP squared. So VDD minus ID, which could be obtained using this formula, times given RD minus BDS equal to 0. So based on mo to say BDS. Sige daw. I think it's best to solve an example. Okay. 1.5 volts. RG is 1 mega. 12 volts. 1.2K. Okay, I think everything is set. Except for the device parameters ni Jfet na to. So, base specs, IDSS is equal to 12 milliamperes. And VP is equal to negative 4 volts. Na. Okay. So, what is required? ID and VDS. Hindi naman tayo need mag-solve ng IS, kaya naman tayo ID. And the ID is equal to IS for Jfet. So, muna na ito pangitawan si ID o VDS. So, kung mag-KVL tayo dire, that's BEE, VGG. Ito diba? Pwede ito derive, pwede ito dito. VGS is equal to VGG. So, kung ito i-derive, yan may tabo. No? KVL tayo dire. 1.5 minus 1 mega. That is IGRG. IG 1 mega ohm minus VGS 0. Diba? GS. So, KVL na dito yung 1.5 minus 0 minus VGS equal to 0. We know that this is 0, therefore, VGS is equal to 1.5 volts. So, natin VGS. ID is equal to IS. Okay, wala pa tayo magbuhat ana. So, based sa aning derivation ngayon na, VDD minus IDRD minus VDS. Ang given naman dito kay si VDD, which is 12 volts. Si RD is 1.2K. So, si VDD o si RD given, si ID o VDS dili. Kailangan na ito makuha either si VDS or si ID una. No? But again, mas better unahon si ID because naman siya formula. Shaklee Equation. ID is equal to IDSS 1 minus VGS over VP. Sige. ID is equal to IDSS 1 minus VGS over VP. IDSS is given 12 milliamperes. VGS, what is VGS? 1.5 volts. And VP is equal to, given man to ganina, negative 4. Negative 4 ni supposed to be. So, positive na ako ni. Squared na ba? No? Squared. Okay. Number mo na ni. Sabi? Given na si VGS ba? So, sila ni. ID is equal to, pila ba ni? Twenty-two, 23 nanoamperes. This is 12. Ay, may kulang akong Shaklee equation ba? S 1 minus VGS over VS. Ano naman? Over VP. Ito, 22.69. Twenty-two point 69 milliamperes. Base nyo na compute. Okay. About VDS. Hindi naman itong VDS. VDD minus IDRD minus VDS. Diba? VDD minus IDRD minus VDS. VDD is 12 volts. ID is this one, 22.69 milli. RD is 1.2 kilo ohms. Negative 15.23, no? So, negative 15.23 volts. Hmm. Mm-hmm. Tuman, did everybody get the correct answer? Okay. How about this one? Mm. Anong given? Okay. So find VGG and ID. ID, of course, BDS, and BGG. Hmm. Well, there's a given because this is a fixed bias. VDD is equal to VD, which is 9 volt. And 9 volt is measured from here to the ground. Diba? And our source is connected one to the ground. So it's as if saying is also equal to VDS in this case. No? So VDD, sorry, VDS is equal to VD is equal to 9 volt. Kung mag-KVL to dire, na-show na to earlier that VGG is equal to VDS, VGS, no? VGS. So, na naman tayo VDS, mag-use ang Shaklee equation, ID equal to IDSS 1 minus VGS or VP squared. So may given the ID is unknown. No? IDSS is 8 milliamperes. Yun sa mo, JFG. Shift solve. Okay. IDSS is 4 milliampere, 8 milliamperes. VGS is unknown. Ano no? Lagi. VGS is unknown. Ano naman ikuan? No? Asa to? Agi ohms law ni mo ni. IDS is 0.0845. Yes, ano yung magpagawa, Jave? Dahil lagi ako ha. Sige. VDD is 14 volts. VD is 9. So, pila ang VRD? VDD is 14. VD is 9, meaning measured from the drain to the ground niya. So, pila ang VRD? And VRD is not equal to VD ra ba? Pila ang voltage drop sa RD? Okay, very good. 5 volts. So, 14 minus 9, 5. No, I think clear man siguro. Para klaro ha, lahi ang voltage sa RD o lahi po ang VD. Ang VD is measured lang from this point, from the drain to the ground. Whereas VRD is the voltage drop sa atong resistor. So if VRD is 5 volts, VRD is 5 volts, therefore ID is equal to VRD over RD. Correct? Ohm's law. Which is equal to 5 over 1.6K. Meaning, ID is equal to 3.125 milliamperes. 3.125 milliamperes. That is our ID. Model natin i-plug. VDD minus IDRD. Yes. Oh, this is the same ano bito kanina, oh. Katong i-derive pa. VDD minus IDRD minus VDS equal to 0. Diba? Diba kung KVL ta dire, muna ito makuha. If na natin ID, solve na to ni. The only unknown here is VGS. So ID is 3.125 milli is equal to 8 milli 1 minus VGS over negative 4 man eh. So, gi-plus lang na ako kapag mawala ang negative ni negative 4. Plus VGS over 4 squared. Solving for VGS, negative 1.5, yes. Negative 1.5 volts. And that is also the value for VGG. So the same gyapon sa BJT, compared to the fixed bias, mas stable ang emitter bias. So tungod kay sa FET, laman tayo emitter na terminal, source terminal man na. So ilang gingan lang tong yung equivalent sa FET as the self-bias, no? Self-bias configuration. So almost equivalent na gid ni sa emitter bias sa BJT, no? Ito ha. So if man niya itong device, natay RS, natay RD, same. And ang difference lang ani sa fixed bias is wala na itong VGG. No? Alay na connect ng RG and diretso na din sa ground. So this is a self-bias configuration for FET amplifiers. No? So duha gyapon natong KVL loops. One here. And another here. Yeah. KVL pa diha sa first loop. KVL ta dire. So may convention ni ito. Connected mo si RG sa ground. Well, di mo matter, no? If pa dito ang iyang current flow, so resistor man siya, buwas mo gina ang current sa resistor sa negative. So, nga na. Pwede na gyapon matter nga naman, zero man gyapon ang IG. No? So, para lang ni sa pag-derive sa equation. No? Negative IGRG minus VGS minus ISRS is equal to 0. Okay. Then again, this is 0. Therefore, VGS is equal to negative ISRS. Makuha ninyo? Anong yan na iyahang equation? IGRG minus VGS minus ISRS. But IGRG is equal to 0. Therefore, VGS is just equal to negative ISRS. Yet, ID is also equal to IS. You could restate this equation as VGS equals negative ID RS. Question so far. Sabtan, kung gusto na pag-derive. Okay. Next. Sa output side, the same nagyapon kanina. With just the addition of RS. VDD minus IDRD minus BDS minus ISRS. VDD minus IDRD minus BDS minus ISRS to 0. Wala may makancel no, kaya wala may 0. But pwede natin makombine si IDRD ug ISRS. Because ID is equal to IS, i-replace na to si IS ug ID the same sa atong gibot kanina. Combine ni siya, no? So si VDD man ni siya itong ginapangita, transpose si VDD to other side. VDS I mean. VDS is equal to VDD minus ID RD plus RS. So akong giipon si ID RD ug ISRS. Kaya parehas naman si ID ug IS. Yung mga siya ani. Kuha. Sige. So let's try to solve one last example sa self-bias. And gusto na ko ni-emphasize because aside sa fixed bias, tanan nga solution sa with regard to FET, basta kay analysis lang, ingani na dayon ang format, no? Ingani ang steps. Okay. Sige, example ta. Example number 3. Given a self-bias configuration, okay, atong circuit, ng specifications, ADS is SS is 10 milliamperes and BP is negative 4 volts. Okay. Find same gapon, ID and VDS. So based sa itong nakuha kanina, na-derive, kung lang islat daan, VGS is negative IDRS. And VDS is VDD minus ID quantity RD plus RS. So ito na ako daan. Okay, kulang. Sa mga knowns dire. Si VDD is known. RDRS known. Known na siya. So, na tulo ka unknown. No? Si ID, si VGS o VDS. So, we have 3 unknowns but only 2 equations. Kulang tag isa ka equation. No? Again, ha, kanis lagi pang derive natin sa daan based sa atong self-bias configuration ng circuit. No? Using KVL. But di natin ma-solve kay tulo na itong unknown. VGS, ID, and VDS. Kulang tag isa. Sa katong isa. ID equation. So, tawag ito naman siya name. Shaklee Equation, di ba? So, very good. ID is equal to IDSS 1 minus VGS over BP squared. Okay? So, magamit din siya. Now, yan usually ang step sa pag-solve of analysis sa FET amplifiers. 1, pangitawon ang equation na mag-relate kay VGS and ID, which is this one, no? Or ang KVL sa input side. Ganun siya. Next step, i-substitute nato ni siya dito sa VGS dire. No? So, if i-substitute nato ni siya kay kuan, so let's say this is equation number 3, Shaklee equation. Substitute nato si equation 1 kay equation 3. It becomes ID is equal to IDSS 1. Negative man si VGS. Negative po ni. So, pwede lang ako na i-plus. Plus. Instead of VGS, replace na ko og IDRS. ID RS over VP squared. Okay. One equation, one unknown. ID. Given man eh. Given po si VP. Given po si RS. So, one equation, one unknown na. Diba? Sige. So, ako sa i-change si ID into X para mas dali ma-visualize. No? X is equal to IDSS is given as 10 milliamperes. 10 milli, 1 plus RS is 750 ohms. 750 times ID, which is X. over VP is negative 4 squared. Okay, solve for X. Kinanglan i-expand. Oh, 2.61. Sige. Ako na i-check kung kuan ba na. I-shift solve ra nimo. Okay. Yeah, i-shift solve nimo. Ano ko follow-up question. Okay. So, okay naman na shift solve kung matimingan nga ang nagawas nga answer is the actual nga answer. No? Usually, diba, basta nga ni duha ka answer mo gawas. No? Ako explain later na it might be nga mong gawas sa shift solve is dili necessarily ma-auto. No? Duhang mo gawas sa ning answer. Okay? Sige. Kung expand na to ni, this is 1 plus 2 times kana siya. Expand og kuan ng binomial dito ni. 750 divided by negative 4 times 1 times 2 minus 375 x plus nga na distributed milli okay lang, itay lang ako og kuan na. Then minus 1 dire para may mo siyang quadratic equal to 0. So 5625 over 16 x squared minus 4.75 x plus 10 milli equal to 0. So natay do ka x mong gawas. Okay. Isa is 1, 2, 3. 10.9 milli. Ang isa is 2.61. Okay. 2.61 milli. Inyo nakuha is 2.61. Okay. Now, asa ka sa duwa ang more logical aside sa fact nga nakuha ninyo ni using shift solve. So na more logical na reason nga nung we should choose one over the other, no? Na to atong saturation current, IDSS. How much is IDSS? 10 milliampere, no? 10 milliamps. So, asa sa duha ang dapat nga value sa atong ID? Di na ni pwede. 10.9 naman eh. 10 milli rabi atong IDSS. So, ang isa atong piliyon, 2.61 milliamperes. 2.61 milliamperes. That's why I would suggest nga i-expand gid ninyo ang quadratic equation sa kaninga part, kay wala man ta kabalo asa sa duha ang pwede magamit, no? So if ID is 2.61, i-substitute lang naton na siya dire para mo si VGS, no? So VGS is negative ID RS. Negative 2.61 milli times RS of 0.75 kilo. Negative 1.96 volts. Okay. Ano ba to? Find VDS pod. VDS. VDD minus ID, RD plus RS. VDS is equal to how much is VDD? 18 minus 2.61 kilo times RD of 1.5K plus 750 ohms. Uh, 12.13 more or less. Same tag VDS. So kung i-review ang steps of course first, panguha na to ang mga KVL equations, KVL ta dire, and KVL ta dito. That's why nakakamap ta og equation 1 and equation 2. So sa equation 1, ano yung relationship ni VGS and ID, magamit ni later, sige, ako nang ikuan. Answer in a while. Pero I think imong pasabot is what if ang duha kay ubos kaysa IDSS, dili VDD. So if mo kuha na itong relationship ni VGS and ID, gamit natin siya, kaya muna ito i-plug sa Shaklee Equation. So, mo gina yung pamaagi sa pag-solve for ID, gamit sa Shaklee Equation and the relationship of VGS and ID. Dire. Ato gining i-mano-mano. Ang tulong ako ata og duha ka values. Piliyon din nato, no? Asa sa duha ang mas ubos kaysa sa naka-specify nga IDSS, no? So So if dili pa lang daan ato nang ma-eliminate ang isa, so clearly mo ni siya ang atong ID. Now na instance nga yes, what if both sila mas ubos, no? So i-test na po nato. Okay? Substitute nato ang first dire sa atong equation 1 and the same gyapon sa second, no? Second kani dire. Now dili pwede pod nga mulabaw ang atong value ni VGS sa kaning VP. Maupod kibali niya ang maximum value for VGS, si VP. And so far, no, sa akong mga nabantayan, wala naman siguro malampas pa o value ana. No? Naging na isa nga mas ubos. Okay. So, sila ang atong mga kuan kibali, sila ang atong maximum values, no? For drain current and VGS. And after that, substitution naman dayon, no? Solve na dayon nato ang VDS and VGS. Okay? Mo gyapon nga process kung mag-solve na to og voltage divider o katong more other configuration na circuits for FET amplifiers. Mo gid yan siya pamaagi, no? So, mo lang yung lisod nga part sa kuan sa FET. Although wala na kay tayo memorize ng formula, kanilang iskabuok, kaning Shaklee Equation. But other than that, kaya ra, no? Or relatively easy ra gid siya ang FET, no? FET biasing. Samot na pohon, no? Samot na sa FET amplifiers. Mas appreciate na to ang atong na earn nga skill sa BJT amplifiers kay masayon i-handle ang FET amplifiers. Okay? Questions so far? Clarifications? Was everything clear? Napay gusto i-clarify? Okay, if wala na, pwede na mag-dismiss.